Hello, welcome everyone. My name is Sadat Sudi Mohammed. I am a mathematics teacher. Today we learn about congruence. Have you heard that? Congruence. So at the end of this lesson, you'll be able to define congruence in geometry. Define congruence in geometry. But also to state the properties of congruent figures. State the properties of congruent figures and prove congruence of triangles. Before we proceed further, let us have a simple activity. Please observe carefully the following short videos. Number 1, here we have two mathematics textbooks. Book 3 and other one is book 4. Please check the video. Let us put them together to see if they fit exactly or not. What have you observed? Did the textbook exactly covers each other? Yes, Amne? Excellent. The textbook superimposed each other, exactly cover each other. Now we have an orange here cut into two pieces. Here the first piece, and this one is the second piece. Now let us put them together to check whether they can exactly cover each other. Please check it properly. What have you observed? Who can tell us? Did the pieces exactly cover each other? Yes, Mbaruk there. Absolutely. The hemispheres cover each other exactly. Now let us see one more example here. Please check the video. We have a triangle. We have triangle A and other triangle B. Now let us try to fix them together to see what happened. Did they cover each other exactly? Yes, very good. The triangles did not cover each other exactly. So now, my dear viewers, let us think and try to answer the following questions. Please try to think deeper before we attempt the following questions. Why the textbook did they superimpose each other? What is the reason? Moreover, why the triangles did not superimpose each other? Yes, try to think deeper and deeper. What have you found? Who is ready to give us an answer? Yes, Mariam over there. Oh, very good, excellent. You found that the textbooks have the same shape and dimension. Fantastic. Let us clap 3 times for Mariam. What did Mariam found? Can you tell us what did Mariam found? Yes, Mariam found that the textbook have the same shape and dimension. Oh, very good. So now what about triangles? What about triangles? Yes, Ridwan. Tell us, please. Oh, absolutely. Fantastic. The triangle size and dimension are not the same. Of course, that's why they did not exactly cover each other. So, the figures that have the figures that have the same shape and dimension are called congruent. Say it, congruent. Yes, the figures that have the same shape and dimension are called congruent. Therefore, my dear viewers, we can define congruence as the state achieved by coming together. State achieved by coming together, or you can say state of agreement. Congruence is what? It's the state achieved by coming together, or the state of agreement. In other words, we say that two objects are congruent if they have the same dimension and the same shape. Two objects are congruent if they have the same dimension and they have the same shape. So remember that shape and dimension are the basic properties for congruent figures. Shape and dimension are the basic properties for congruent figures. If you lay two congruent triangles on each other, they would match up exactly. Why? Because they are congruent figures. And example number 2 says, prove that the sum of two interior angles of a triangle is equal to the exterior angle of the third interior angle. Okay? Prove that the sum of two interior angles of a triangle is equal to the exterior angle of the third interior angle, Okay, now let's move. Solution. Okay, first of all, let us construct a triangle. Triangle ABC. Okay, and this is our triangle ABC. This is a nice one, at least. Okay, so we have A, B, and here C. So from this triangle now, we have to extend. Let us extend the line here, and so we have the line BD. Here is D. So we want to prove that sum of the interior angle, two interior angles, which is CAB, this angle, and angle BCA, which is this one, is equal to angle this angle, which is CBD, this angle. Want to prove that this angle, which is CAB, plus this angle, which is BCA, or ACB, is equal to the angle CBD. This is the exterior angles of angle of a triangle, and these two here are the interior angle of the our triangle. That's good. Okay, proof. So let us prove now. First of all, we have a triangle in which we have the angle ABC, angle ABC. If we sum it with the angle BCA, angle BCA, and plus angle, the rest angle here is CAB, this is equal to 180 degrees. Why? Because these three angles are the interior angles of a triangle, so their sum is equal to 180 degrees. So the reason here is sum of interior angles of a triangle. Sum of interior angles of a triangle. So there's no problem for that. But our issue here is to prove that, to show that the sum of these two interior angles of a triangle is equal to exterior angle. Okay, but also here we have straight line, the straight line AD or ABC. So from this straight line we can also have some relation here of the angles, and we can see here that the angle ABC, if you sum up with the angle CBD, this angle CBD, this also is equal to 180 degrees. The reason behind here we said the line AB, this is a straight line, so this is the degree measure of a straight line, or we call it straight angle. So that's the degree measure of a straight angle. Okay, that's nice. Hope we are moving together. Yes. Now we have the first equations that says ABC plus C plus BCA plus CAB equal to 180, and we have another equation that says ABC plus CBD and we have another equation that says ABC plus CBD is equal to 180 degrees. So this implies what? This implies that ABC, this angle, plus angle BCA plus angle CAB plus angle CAB, this is equal to, because since it's 180 degrees and this is also 180 degrees, so this is equal to that one. So this equation is equal to that equation, which is angle ABC plus angle CBD. Are we together? Yes, because the sum of these two equations, of the sum of the angles for these two equations, all of them is equal to 180 degrees. So this have to be equal to this one. So now we can see here ABC here at the left and ABC at the right. So this they cancel each other because it's an equation. So what remains here is angle BCA plus angle CAB. This is equal to angle CBD. Okay? What is BCA? And what is CAB? And what is CBD? Now let's turn back to our triangle. So we have seen that angle CAB plus angle BCA is equal to angle CBD. So these two angles, which is CAB and BCA, are the interior angles of the triangle, and CBD is the exterior angle of the triangle. So hence, this also is proved. So therefore, we can conclude that sum of two interior angles in a triangle is equal to exterior angle. So hence, the sum of two interior angles of a triangle is equal to exterior angle. So this is also proved. Okay, example number 3 says, prove that the bisectors of the angles formed by two intersecting straight lines are at a right angle to each other. At a right angle to each other. Okay, so first of all, let us construct two intersecting lines. So let's say we have a line, these two intersecting lines. Let's call it line AB, and let's call another line as CD. So these are two intersecting lines. And now let's say we have the bisectors of the angles. We have the bisectors and another one. Let's say we have the bisectors now, which is RS. Let's call this RS, and let's call this one QP. And let us assume that we have the angles now here. Let's call this angle A, and let's call this one angle B. This one, let's call this one angle B. So if this is A, also this one is going to be A, because these two angles are vertical opposite angles. And if this is B, also this one is going to be B, because these also are vertical opposite angles. Then let's say we have A here, and if this is A, also this one is going to be A, and let's call it B. If this is B, also this one is going to be B. We want to prove that bisectors of the angles formed by two intersecting lines. Bisector this one, the P, this angle here is right, is 90 degrees. That it is formed with two intersecting line with the bisectors. So we want to prove that A plus B is equal to 90 degrees. We want to prove that required to prove that A plus B is equal to 90 degrees. That's good. Now from the figure, A plus B plus A plus B then plus A, this is equal to 180 degrees. Let's check it here. This A plus this B plus this B plus this A is equal to 180 degrees. You check. Why? Because this is the degree measure of a straight line. That is the degree measure of a straight line what? Straight line QP. All of these angles lie on the straight line QP. So their sum has to be 180 degrees. So the reason behind is degree measure of a straight angle. Degree measure of a straight angles. If that is true, then if we sum up here A plus B plus B plus A, it's going to be 2A plus 2B, and this is going to be 180 degrees. Okay? And this implies what? This implies that A plus B is equal to 180 degrees divided by 2. Then we'll have A plus B, this is equal to 90 degrees. And this is what we are supposed to prove. Hence, we conclude that the bisectors are at right angles to each other. So, therefore, the bisectors are at right angle to each other. This is what we're supposed to prove earlier. The bisectors here are QP and RS. So we're supposed to show that these bisectors are at right angles to each other. Okay, this now is your exercise, is your take-home assignment. And question number 1 says, use the figure below to prove that angle ABD is equal to angle ACE. Use the figure to prove that angle ABD is equal to angle ACE. Question number 2. Prove that angles BCD is equal to angle CBA. Prove that angles BCD is equal to angle CBA. And the final question, question number 3 says, if the line AC bisects angle BAQ, Prove that x is equal to z. If the line AC bisects angle BAQ, prove that x is equal to c. So this is your take-home assignment. Now, let us see the summary of our lesson. Two objects are congruent if they have the same dimension and same shape. Remember that? All congruent figures are similar. All congruent figures are similar, but not vice versa. This means what? This means that all congruent figures are similar, but all similar figures are not congruent. Congruence is the state achieved by coming together, or the state of agreement. Like this. Hope you enjoyed a lot from this lesson today. Do not forget to make revision from your textbook. Thank you and have a good day. Bye-bye.